In this problem here, question number 7, we have a 3 by 3. A 3 by 3 is when you have 3 equations and 3 unknowns. 3 unknown variables. So that's called a 3 by 3. So 3 unknown variables. So here in this problem, you need to solve for x, y, and z. So how do we solve a problem with x, y, and z? So here I rewrote the problem. The first step that you're going to do is your goal. So your goal is to make this 3 by 3 make this become a 2 by 2, meaning you want 2 equations with 2 unknowns. 2 unknowns. So that's your goal for the first step. The first step is you want it to become a 2 by 2 instead of a 3 by 3. This is a 3 by 3. 3 variables and 3 equations. You want 2 equations and 2 unknowns. So what you're going to do to get to this goal is you're going to look at the 3 equations and you're going to choose 2 equations and eliminate a variable. So choose any 2 equations and eliminate 1 variable from them. So let's just go ahead and pick here's equation 1, equation 2, and equation 3. So let's go ahead and pick, so I'm thinking which equations, if I added them together using the method of elimination, will I get rid of a variable? And I notice there's a y and a negative y here. If I added these 2 equations, I'll eliminate the y. So I'm going to choose equation 1 and equation 2, and I want to eliminate my y. So what I'm going to do is I'm going to add these 2 equations together. So I have negative x plus y plus 2z is equal to negative 3. 3x minus y plus z is equal to negative 2. So when I add these 2 equations together, this becomes a 0. That's exactly what I want. So I am left with 2x plus 3z is equal to negative 5. Ta-da! I have an equation with just 2 variables. Okay, so now so remember the goal is to make this become 2 equations and 2 unknowns. Here's 1 equation with 2 unknowns. So now I'm going to choose another set of 2 equations and eliminate the same variable as above. So I eliminated y up here, so I need to eliminate y again. So I need to pick 2 other equations where I can eliminate the y. So here, looking at these, so I can't pick 1 and 2 because I already did that. So I need to pick 2 other equations. Well, let's say I need to eliminate the y values. So we haven't chosen equation 3 yet. So I'm going to choose equation 3, and you could choose either equation 2 or 1. It doesn't matter. I'll just pick equations 1 and 3. So I'm going to pick equations 1 and 3. And again, I want to eliminate my y. I want to eliminate the same variable as I did up there. So equation 1 is, I'm going to rewrite equation 1. And I'm going to rewrite equation 3. Oops, it's 2x minus 3y minus 4z is equal to 1. Okay, and just letting you know, it's really easy, common error to human error to, when you're rewriting things, to write the wrong number, when you rewrite it or put the wrong sign. So notice here I was going to put a 3, it was actually a 2. So it's a very common error to make when you rewrite problems, to rewrite them incorrectly. So a hint or a tip for that is to always double check your work. So I tend to make little tiny mistakes. So what I do is after I write it down, I always go back and say, okay, did I write it correctly? And I go back and check. So before I keep going on and doing all this work and spinning my wheels, I want to make sure that I'm working with the right equations. So I always double check my work before I go on to the next step, because I don't want to waste my time working with the wrong numbers. So here I want to eliminate my y, so I'm focused on my y here. Y and negative 3y. So I want them to be opposites of each other, so when I add the 2 equations, they will eliminate. So what multiple do they have in common? 3 and 1, they have a multiple of 3 in common. So I want to change this to become a 3y. So 3y minus 3y will give me a 0. So I'm going to multiply this whole thing by 3. So I'm going to multiply this whole thing by 3. So when I multiply it by 3, I end up getting negative 3x plus 3y plus 6z is equal to negative 9, because I multiplied by 3 to every single item in this equation. And the bottom stays the same. I'm not changing the bottom at all, so I leave that the same. And once I do that, now I can add my two equations together, and notice the 3y and the negative 3y cancels out and becomes a 0. So here I'm left with negative x plus 2z is equal to negative 8. So here you go. My goal for step 1 is to create a 2 by 2. Here's two equations with two unknowns. So now we're going to go to step 2. So step 2, so now that we have a 2 by 2, well, that's exactly what we've been doing this during this worksheet, early in this worksheet. Now that we have a 2 by 2, we can work with these problems, right? Because here we've had 2 by 2s, and we've solved for the 2 by 2s using method of elimination or method of substitution. So now that we have a 2 by 2, we again use, and we've been using the method of elimination or addition, whichever one you want to call it, to make it a 1 by 1. And a 1 by 1 is one equation with one unknown. So here, I'm going to rewrite these two equations that I put in red boxes. 2x plus 3z is equal to negative 5. So 2x plus 3z equals negative 5. Negative x plus 2z equals to negative 8. So negative x plus 2z is equal to negative 8. And I just want to double check because I tend to make mistakes. All right, so this is my 2 by 2. So I want to get rid of one of the variables. So just like what we have been doing in the beginning of this worksheet, I'm going to get rid of one of my variable. Which variable do I want to get rid of? Let's just say I see the 2x and the negative x. I want to get rid of my x. So I want to get rid of my x. And if I want to get rid of my x, I see that the common multiple is 2. So I'm going to multiply this whole thing by the number 2. So when I multiply this by 2, I get negative 2x plus 4z is equal to negative 16. This top part stays the same. I get 2x plus 3z is equal to negative 5. So as a result, when I add these two equations together, this becomes a 0. When I add these two equations together, I get 7z. When I add these two together, I get negative 21. So now I'm going to divide both sides by 7. So as a result, this becomes a positive 1. So I get z is equal to negative 3. So now I've solved for my z. So now that I've solved for the z, the last step now, step 3, is plug your known variable, which was this one, we know z was negative 3, into the previous equation to solve for the other variables, equations for other variables. So now we're just going to go backwards, and we're going to plug this back into the previous equation. So z equals negative 3. I could plug this into either one. It doesn't matter which one. So I'm going to plug this into, say, the second one. So I'm going to plug this into negative x plus 2z is equal to negative 8. I know z is negative 3, so I'm going to say negative x plus 2 times negative 3 is equal to negative 8. So I end up getting negative x minus 6 is equal to negative 8. Add 6 to both sides. See, I wrote an 8 by mistake, so I need to always double check. So I get negative x is equal to negative 2, so x is equal to positive 2 when you divide both sides by negative 1. So x is equal to positive 2. And now, last but not least, now that I have my x and my z, I just need to solve for y. So x is 2, z is negative 3. What is y? Well, I go back to the original problem, and I plug it into any one of these. So you could plug in anything. I think I'll just plug it into, it doesn't matter which one, I'll plug it into this one. So when I plug it into this one, I have 3 times x. Well, we said that x is 2 minus y plus z. And what is z? Z is a -3 is equal to -2. And now I just want to solve for y. So I get 6 minus y minus 3 is equal to -2. 6 minus 3 is 3. So 3 minus y is equal to -2. I subtract 3 to the other side, so I'm running out of space here. So if I subtract 3 to the other side, I get y is equal to -5. Divide both sides by -1. So I end up getting y is equal to 5. So the end answer is that x is 2, y is, what was that, 5, and z is -3. So what that means in terms of a graph is now that you're dealing with 3 variables, you're dealing with 3 dimensions. So before we just had 2 dimensions going on, right? The x and the y. Well, the third dimension is the z value. So in the z value, we have 3 dimensions going on. So with the 3 dimensions going on, we have 3 different lines, right? So you have, I'm just going to draw whatever. So you have 3 different lines, whatever, right? And where they intersect is the points 2, 5, and -3. So they share a common point on a 3-dimensional plane. Now, I also want to say something about these systems of equations. So here we have a 3x3. So I'm done solving the problem. I'm going on a little bit of a tangent now. This is a 3x3. As you get into higher math, you're going to get a 4x4. 4 equations with 4 variables. A 5x5, a 10x10, a 15x15, a 100x100. You could have thousands of equations with thousands of unknown variables. And the question is, how do you solve for that, right? So if you guys are going to college algebra, or even, college algebra and higher, if you have something that's a 3x3 or a 4x4 or a 5x5 or 6x6, you will not be using the 3 methods that I showed you in this class, which is graphing, substitution, and elimination. You're going to be using what we call a matrix. So a matrix is really a method of elimination on speed, basically. So you're going to be using a method called the matrix system to solve for these, and it really is the method of elimination. And then for those of you that are interested into going into computer programming or whatnot, as these equations get bigger and bigger, you learn how to program these matrices into the computer, and you let the computer solve it. And this is very relevant to real life, because in real life, there are not just 3 unknowns. There are hundreds of unknowns. So lots of things in real life have a lot of unknown factors and variables, and we use computers to solve for them. When I was getting my master's in math, I did a project on how Google ranks their ads. And how Google ranks their ads on the internet is that they looked at so many different factors. They look at, how many times has that page been hit on, how many links are on that page, a lot of different factors. And then they use basically a matrix to determine how to rank the ads on Google. So it's very relevant to real life. And for those of you that are going to computer programming, this is something that's you'll see again and again.